So hello everyone. In last video we have covered a proper introduction to the curves, and in this video I'll be introducing you to some of the tools which are used to analyze them. So let's open Rhino. So you can see there's a lots of components. So this video is gonna take a time. So hold back and relax. Uh, so if you go to the curve and you will see the analysis section. So I have chosen most of them for you. So let's go. So you will see the in input parameters I have been using a curve. That particular curve is this one, the yellow one. If you I will click on it, you will see it gets green. So let's start with the first curve. The first curve analysis component is the curve middle. When you connect it with your curve, and you can see it has already shown a point here. So the output is actually the midpoint coordinate. When you connect it with the panel, you will get the coordinate. So let's go next, pressing Control and dragging for removing the connection. And the next one is end points. What it does, let me remove this one too. Yes. So next one is actually when you connect with a curve, it gives you the starting and the end point coordinates. That is this one and this one you can see in the Rhino. And when I connect it with the panels, you can see the coordinates showing up here. This one is the starting coordinate and this one is the ending coordinate. And let's go to the next one, evaluate length. So let me connect this curve with the component. So I have connected this curve right now. The second parameter is the length. So it actually reparameterize the length in whatever we give from the slider. So consider if there is a length L and I'm giving the slider between 0 to 1, so it divides the length between 0 to 1. So when I connect it, so let me preview of it. So preview is off. So focus on this particular point here. So when I change this one, you can see there's a point moving. So this is length factor. So let's see what we get from here. The first thing that we get is the location of the particular point that we get from this, the particular length factor. So the coordinate of that particular point is this one, and the next is the tangent of the curve at this particular point. That is this one, and this is a curve parameter. There's a difference between the length parameter and the curve parameter. In length parameter, we actually reduce the whole length into a particular parameter that we define, like I have defined between 0 to 1. So if you connected this the one, you get the the curve parameter. So let's go next. Next one is the discontinuity. What it is, let me turn off the preview first. So discontinuity, what it does, it shows you the point where the curve is actually discontinuous. In our case, the curve is discontinuous at 2 points, the starting point and the end point, because there's no in this case there is no LHS or left hand continuity, and there is no right hand continuity. So let's see what else it needs. Uh, it The second input parameter is a level of discontinuity. We know that the continuity is basically if you say level 1, that is a tangent. That is a, if we differentiate a curve for the one time, then we get the first level of discontinuity. If you differentiate it for the 2 times, you get the second level of discontinuity. So this is what it is. So if you want the check, if you want the points of discontinuity of second level or third level, you can pick up a slider and put it here for that purpose. And let's see the outputs. It gives the first output is the point of discontinuity. So our points of discontinuity are here in this particular point, and the second one is a curve parameter. Yes, connected with this one, the curve parameters at which it have found the discontinuity. The next one is extremes. What it does, it finds the extreme values of your curve. And there's one interesting thing, let me show you. If you can look at, it says the second input here is the plane, like on which plane you want to find the maximum and minimum value, and the output are the highest point and the lowest point. If you can see here, right now it is finding on the XY plane. Here you can see in the description, it is finding highest points on this highest and lowest point on the XY plane, and right now our curve is in the XY plane. So the maximum and minimum both values are 0 right now, you can see. So if you can our actually let's find the maximum and minimum point in XZ plane. I got this from vector and plane here. So let me connect the plane here. Right now the values we have gotten here. So this is our maximum value and this is our minimum value that are actually visible in the panels. So let's go to the next one is a let me turn it off the preview. Yes, so next one is a curvature. It actually evaluates the curvature at a particular the curvature domain. So yes, I have connected the curvature here, and the next thing that you see is a curve parameter. In the last cases you have seen we were getting the length parameter we have used here, but here we have to use the curve parameter to know the curve parameter of this whole curve. Let's connect this one to this. So let me find so we can see actually the curve parameter varies from 0 to 83.45. So let's edit the slider. So it has to be between 83.545. Now we are done. So let's connect this with the parameter. Now you can see when I change the parameter, it draws a circle according to its curvature at every point as we change the curve parameter here. So let's see its output. The first output is the point on the curve, like on this particular curve parameter. What is the point? If you connect it with this one, you get the point. And the next one is a curvature vector at this particular point. And the last one is actually the curvature circle. So if you want to extract this circle for further processing, you can do that. And the next one is the length. This is pretty much simple. You get the length of your curve. So the length of curve is 53.18. The next component is a control point. Okay, let me turn off the preview first. So in the last video I have told you that these curves are actually controlled by the control points. So this particular component helps us to find out the control points. Let me connect this one. So you can see the control points are now visible in Rhino. So its outputs are, the first output is a list of those points which you can see in the panel, and the next one is a weight of each control point. You can see the influence of each control point is actually the same. So if so the influence value is actually defined by the weights on any curve. And the last one is the knots vector. I have a little bit described about it in the last video. And the next one is derivative. Yes, derivative is a kind of bit used thing. So it also takes the curve parameter. So let me connect it with this one, the curve and this. So preview is off. So you can find the derivative at any point. So it gives the point at that particular parameter, curve parameter it have given, and the last one is the value of derivative. So you can see, you can easily manipulate it. The next one is closed. It's pretty much simple. It actually tells whether your curve is closed or not. It will give, if it's closed, then it will give true at this particular C. Otherwise it will So this curve is not periodic and this curve is not closed. So in both cases we get the false. So our next one is the curvature graph. What it does, it draws the the curvature graph according to the variation. So we have to just connect it. Now you can see the points where the curvature is most changing. We can see the more deflection here. So let's hide it and go to the next. So there are a few more left, and for them we need two curves. So the first one is curve proximity. What it does, it measures the distance between two curves, and it does many things. So this one is represent the upper curve and this one represent the below curve. So connect with A and B, which input is the curves. The outputs are the A is the point on curve A closest to B. So point this one, and B and D. D is actually the distance. D tells the minimum distance between them. And the next one is a curve closest point. So let me turn off the preview. For that purpose we will need a point here. So let's put a point. So we have put a point here. Let's bring yes, we need a point here. Yes, I got one. So click on the point and set one point. So we got our point. So the first parameter is actually the point. Second is the curve. Now let's see the output. The first output is the point on the curve which is closest to the base point. Wait. Yes, we got the data. So you can see. Let me connect all of them. So the first output is point on the curve, which is the point on the curve which is closest to this particular point. So this is this point, and the coordinates are this one, and the parameter the curve domain. So it gives the curve domain, and last one actually gives the distance value. So the distance between this upper point and the point on the curve is 11.54, and the last one is very important, but I'm not going to tell it by example. You can look through it. Is a deconstruct arc. It is a very important because when we make projects we have to work with the arcs. So what we do, we input the arc over in A, then we get its base plane in B and its radius and the angle domain in radius of arc, like in how much angle the arc is actually adjusting. So we are finished with the arcs curves right now. So in the last video we have covered the curves, and we have covered even the curve analysis in this one. In the next video I will be introducing you the surfaces